Hello students, this is Professor Mohammad Shahid Ansari from Maharashtra College of Arts, Science and Commerce. Welcome to the session 9 of Android programming. In this session, we discuss the basic application structure of the Android. The topics to be covered in this session are Android Manifest.xml file, resources and R.java file, absolute layout, table layout, ScrollView layout, activity and activity lifecycle. These are the basic topics that makes the application structure of the Android. Now, the first is your Android Manifest.xml file. This is the manifest file for your Android application. In this file, we specify the permissions needed by your application as well as other features such as intent filters and receivers. Suppose I want to set the permission. Suppose there is a music application that requires the permission for allowing the music to play. The permission is set in Android Manifest.xml file. In the same way, the other permissions can be set in this file. The basic structure or the basic code of this file is this. The first tag is your XML, that indicates it is the XML file. In this, all the code is written by using a XML tag. There is a standard manifest tag which indicates that it is your manifest file. There are the attributes of the manifest file. These are the attributes. Here we can set the permission of the application. Now, what are these attributes? That it will be seen in the next slide. Now, first, it defines the package name of the application as. Now, first thing, the Android manifest file is defined as your package name, which is your hello world. The version code of the application is 1. The value is used to identify the version number of your application. This 1 indicates that the version number of your Android application. This 1 is set by using the attribute Android:version code. This is an attribute which is used to set the version code of your Android application. For the latest version, it is 1. Now, next, the version name of the application is 1.1, set via using Android:version name. This is an attribute which is used to set the version name of your Android application. Next is your we have to define the launcher name, iclauncher.png. This is your name, which is launcher name, which is available or which is located in the drawable folder. The name of this application is string name app_name. Manifest file also contains the application name. This is your string name. There is a one activity in the application represented by hello world.activity.java. By default, one activity is created by the Android Studio. The name of the activity is given by the user. The extension is .java. It also contains the activity details. The label display for the activity is the same as the application name. Now, these are the attributes that we are using in the manifest file. Now, second is your resources and R.java. Android R.java is the auto-generated file. What does it mean? Like manifest file, we are not creating the R.java file. It is by default created by Android Asset Packaging tool that contains the resource ID for all the resources for resource/directory. R.java file contains all the IDs that are using in your Android application. If you create any component in the activity underscore main.xml, ID for that corresponding component is automatically created in this file. All the IDs, whether it is text field ID, edit text ID, button ID, whatever you drag and drop on .xml file, the ID of that control is already by default added in R.java file. It includes a lot of static nested classes such as menu ID, layout, attribute, drawable, string. The structure of this file is this. This contains the class, that is your R. R is the name of the class, and contains static attributes, static drawable, static IDs. These are the classes, these are the attributes that contained by the R.java file. The IC underscore launcher equals to, this is your hexadecimal ID given by the R.java file. Same for menu, it is using this ID. In this way you can set or you can get all the IDs in R.java file. Now next is your absolute layout. One of the layout is your absolute layout. Absolute layout lets you allow to specify the exact location. That means in this layout we will specify the X and Y coordinates position of the children. Absolute layouts are less flexible and harder to maintain than other type of layout without absolute positioning. In absolute layout we have to specify the exact position, exact coordinates of the component or a control. If the coordinates are not proper, there may be chance of overlapping the controls. Therefore it is very hard to maintain. Why? Because we have to specify the exact location of the control. These are the attributes of the absolute layout. ID, Android : ID, it is common for all the layouts. Android : layout underscore X, this is used to specify the X coordinate value. Android : layout underscore Y, this attribute is used to specify the Y coordinate of the view. Now the basic code for this is the diagrammatic representation. In this there is the exact location 20, 40. 20 is your X coordinate, 40 is your Y coordinates. This is the location where the button is displayed. In the same way, the button 1, the button 3 is displayed by specifying the exact location of X and Y coordinates. Now next, this is the basic structure of the absolute layout. Again, there is an attribute of absolute layout. Absolute layout width and height. Field parent. Now in the button we are using Android : layout underscore X, which is used to specify the X position, and this is used to specify the Y position. In the button 1 and button 2 we have to specify the exact coordinates of X and Y. Same way for the button 2, exact coordinate 225 pixel, 361 pixel. This is your X and Y coordinates. For each view we have to specify these two coordinates value in absolute layout. Now table layout. Table layout is responsible for arranging the components, arranging the views in the rows and columns form. You can use the table row, which is responsible. This tag is responsible to build an individual row in the table layout. This is the diagrammatic representation of table layout. In this there is a row 1. Within row 2 there is a column 1, column 2, column 3. In row 3, column 1 and 2, and so on. You will define the rows and columns. The basic structure of the table layout is like this. Table layout, again there is a width and height. Each and every layout has a width and height, and the value for width and height is field underscore parent. Then within table layout there is a subtag called as table row, where table row is responsible for defining the individual row. Individual row of the table is controlled using a table row. Now scroll view. Next layout is your scroll view layout. In Android, scroll view is a kind of layout that is used to add a vertical or horizontal scroll bar to the content which is larger than the actual size of the layout. Suppose we have a content that is not able to fit on the screen, there is some scrolling functionality required at that screen. That scrolling functionality is achieved by using a scroll view layout. This is used to add a horizontal and vertical scroll bars on the screen. Generally, the Android scroll view is useful when we have a content that does not fit our Android application layout. As I told you, if the content is not fit on the screen, then we have to use scroll layout. Scroll layout will enable a scroll to the content which is exceeding the string layout and allow users to see the complete content by scrolling functionality. Now, the basic structure or the code for the scroll layout is the tag is used scroll view. This is used to define the scroll layout. Again, width and height, match parent, wrap contain. Width is your match parent. That means it will occupy the entire screen. Wrap contain. That means as the controls are added, automatically the scrolling size of the scroll view size is increases. Linear layout. Within linear layout, we can create a view which is larger than your screen. Then you will see the scroll, vertical and horizontal scroll bars are there for controlling your screen. Now, next is your activity and activity lifecycle. In Android, an activity is a window that contains the user interface of your application. Activity is responsible for defining the graphical user interface. An application may have 0 or more activities. In this example, we have an activity called as Hello World activity. The Hello World activity is the entry point of application. By default, Android Studio create an activity that is your Hello World activity. That means it is an entry point of your application which is displayed when the application is start. Activity lifecycle. The activity lifecycle defines the life cycle of the activity. What do you mean by life cycle? It will explain when the activity is created and what are the activities carried out by the activity, what are the steps, what are the transition carried by the activity, and when the activity is ended. This entire process is called as life cycle of the activity. Within life cycle of activity, there are methods. There are n number of methods that are called during the activity life cycle. The methods are on create, on start, on resume, on pause, on stop, on destroy, on restart. These are the methods that are created or that are called during the life cycle of the activity. On create, it is a by default method created by the Android, called when the activity is first created. On start, called when the activity becomes visible to the user. This will create the activity within the memory. And on start, create the activity and it will become visible to the user. On resume, suppose if some reason the activity gets stopped, suppose I want to resume the activity, then we will call on resume method. I want to pause the activity, then we will call on pause method. I want to delete the activity, suppose we want the user to no longer visible the activity, then we will call on stop method. On restart method, called when the activity has been stopped and is restarting again. These are the life cycle methods for activity. The diagrammatic representation of this all the method is this. This diagram indicates the various transitions, various steps that are carried out during the activity life cycle. On create, on start, on resume, activity is running. Then during the running, there may be a probability we have to stop the activity. Then when you call on pause method, it will again go back on resume. Again the activity will be started. In this way, all the methods can be called during the life cycle of the activity. Thank you so much. I hope you understood this session. Thank you.